This video is still part on the preliminaries as part of the review on the algebraic properties of real numbers, which are essential in looking into the specific concepts and proof of topics under real analysis. So let me show you the proof of the expression, the negative of the sum of a plus b is equal to the sum of the negatives of a and b. Even if this might be too obvious for some, we are going to apply the algebraic properties of R in our proof in order for us to establish the left-hand side could be turned to our right-hand side expression. Now let's start with this proof here. So we are going to let first A and B element of real numbers because that is for us to establish the algebraic properties of real numbers. Next is to have this statement. We are going to write here the statement on the left hand side, and then we apply the algebraic properties of real numbers in order for us to arrive to this expression on the left hand side. Now, stating about properties, we are going to apply properties like inverses or additive inverse. We're going to apply associativity, commutativity to arrive for the said expression. Let us have this part here, the negative of a plus b, and let me add two zeros. Okay? So the adding of two zeros will not necessarily affect the value on the left-hand side of the equation, but we are reintroducing zeros because we can transform them later on as the sum of two inverses. And we use two zeros because I would like to come up with two sets of inverses that is for our A and then for our B coefficients. Okay? So please bear with me as I have this proof. This would be equal to negative A plus B. Let me write the first zero as the result of adding the two inverses A and negative A. When you add these two, and since A and negative A are additive inverses of the other, they will actually just result to 0. Okay? So I'm adding that, but it doesn't necessarily change the actual value of the left-hand side. For the second 0, let me reintroduce here B plus the negative of B. Similar concept, this will just result to 0 because B and negative B are additive inverses of the other. We are introducing these two sets because we can see here that negative A and negative B already appeared, and that's actually the part of our goal to show that the left-hand side expression is just equal to the sum of the said two expressions. But of course, we are not yet there. We are going to finalize this by our next few steps. The next few step is by removing of the grouping symbol of the two sets of additive inverses. So we have here negative A plus B plus A plus negative A plus B plus negative B. Okay? I am doing this because I would like us to use the commutative property of addition and later on associativity to come up with new groupings. And I'm going to do this like here, negative of A plus B plus A, and then moving this B here so that I am isolating the negative of A plus the negative of B, this part here, which is again the intended result of our proof here. Again, it's just okay to interchange them because we have the commutative property of addition. And with that, let me regroup A and B. So I'm grouping these two plus A plus B, because there would be additional property that will be introduced later on, and this is still the sum of negative A and negative B. I group this to match this expression here because if I'm going to use the associative property by grouping these two, this is how it goes. Negative, you will have, this grouping symbol, negative of A plus B plus positive A plus B, that's already regrouped, plus this 2. Now, okay, once I group that, let me change the color here. As I group this, we can see that A plus B and A plus B can be found on both terms. And this would introduce or reintroduce the distributive property, but the reverse operation, we can take out a plus b here in both terms, leaving for the first term just negative 1, plus here, by taking that out, we have positive 1 at this area. Still, you have negative a plus negative b here. Hopefully, you were able to follow the ideas of associativity, commutativity, and then distributive property here. That's just the reverse operation. They are all algebraic properties of real numbers, because as we reach here, negative 1 plus 1, that's just equal to 0, leaving a plus b times 0 plus these two expressions here. And whatever will be the value of a plus b, once you multiply it to 0, that's just equal to 0 plus negative a plus negative b, which will then return to just the expression of negative a plus negative b. Looking into our goal, that was actually what is stated here earlier, showing that this left-hand side expression is just equal to this form. Thus, we have now the proof that the negative of the sum of a plus b is equal to the sum of negative a and negative b. This is the proof for this statement. Thank you very much for watching.